Good, Chaka. I hope everyone is doing well. Let me see. Okay, let's start this. Shut that down. Do we have any latecomers? There's two. Let me go ahead and get them. Okay, so like this. This one. Okay. Let's go full screen. All right, I think that's good. Let me share my screen. Start the broadcast. And again, I'll check attendance for the second wave around the 15-minute mark. Let me check. Oh, let me get them. As much as I don't like to do this, but it's okay. Right there. All right. Nope. Okay, that looks good. Let me make sure of one other thing. Okay, that's looking good. Right there. All right. So I know the audio is being pushed, and so far the image is being pushed, but usually have to wait a bit for that. I don't recall being on that screen that long. I'm not sure that you guys can see my screen. I don't recall being on that screen. Yeah. Okay. I got to repush the signal because it is not going through. Okay, let's go ahead and do this. So yeah, that's just the challenge with technology. Like it totally can be temperamental. Let me go view. I thought I let him in. Let me check this again. Got him. Get him. Got him. And this one. Okay. Let him in. And let me re-push the signal. Let's just stop the screen share. CD right here. Share my screen. Start the broadcast. Optimize for video. And start here. So what happens? Okay, just start the broadcast. Optimize for video. All right, it's looking good. Okay, I can see the screen, so that's good enough for me. All right, gentlemen, scholars, welcome, right? Man, we are plugging along. Like, okay, I will say the disclaimer, right? I do acknowledge that, we had 1.7 and 1.8 due last night. And I know that together we're talking about 1.7 and 1.8. But again, me just going through this is like as a courtesy. This is not the pace of the course. This is just me, just taking my time, right? The real learning is in my pre-recorded lectures. I do expect you to kind of be watching, but to be watching those on your own, taking notes as if you're in class and asking questions, right? There's nothing stopping you guys from asking questions before this stuff is due. And we can talk about it. If it's due on that Sunday, you contact me, I see the thing or whatever, we can talk about it, all right? Even if we haven't done it together, because this is not the official anything, what we're doing. Like, because in all honesty, I can be like, did you guys have any questions from the recording? If you don't, then I can stay mute, right? So I'm just doing this just so we can do something live, just as a courtesy. But the real learning comes from watching those recordings on your own, taking notes as if you're in class, doing the accompanying assignments, and then asking questions. And also, another thing, the disclaimer is like, as long as you like kind of go with the system and just trust me, honestly, if you got like 90, like if you did get 10% off on all your homework, and I see that you're close to like the difference between like a B minus and a B or whatever, like, but not a B minus and a B, but a difference, like you're close between difference of a letter grade, I would probably just give you that 10% difference. Like I wouldn't even hold it against you. Like really what this is, I'm not really trying to be strict or anything. What this is really just, I'm really just trying to introduce and touch on these concepts in an effort to get through the end of chapter 4, right? I don't really want to change dates and change a lot of stuff around because my intent is to automate it. 2, I'm trying to keep a certain rhythm, right? So as long as I can see that you're getting the concepts, you're getting the material, the main thing is you definitely want to perform in your exam, right? So we're at the top of week 4. So when I looked at the schedule a moment ago, we were scheduled to be wrapping up 2.4 by the end of this week. So we were supposed to be 2.1 and 2.2 today, 2.3 and 2.4. So more than likely, we'll do 2.1 and 2.2 on Wednesday. I mean, again, there are ways where I can shift stuff around, but for right now, I just want to keep this rhythm. And we'll get caught up before exam 1 because that week leading into exam 1, it's only 2 sections, right? Monday, we're supposed to only do 2.5, and Wednesday, we're supposed to do 2.6. So obviously during that week, we'll do 2 sections on that Monday and 2 sections on that Wednesday, and we'll be caught up, right, in time for the exam. And again, if I see that you're getting your assignments in, even if you took that 10% late penalty, if you're close, I would just give it to you. Like, I'm not even gonna like hold that against you. Like, it's not, I don't want you to guys be so, I'm trying to minimize stress here as best I can, right? Because the topic it's tough. Pearson is different, right? I will acknowledge that it is different. So that's why, again, I do the unlimited attempts. I try to do the least amount of late penalty that I can do and still, like, be okay with it. Like, if I only took up 2%, then students will wait to the very end. You know what I mean? Something to just kind of, So that's neither here nor there. As always, if you have questions, feel free to unmute yourself. I need to go out of my way when we get out of class to make sure to go ahead and update my starfish because I have those records. I just need to submit them. Okay, so we are going to be wrapping up chapter 1 today. I'm just going to continue at the pace that we're at. Again, I'll check attendance again in about 7 minutes for anybody that came late. I got a few people pop in after the first wave, but it's okay. So we have a couple of more concepts. So today we're going to work on 1.7 and 1.8. Right now we're going to work on section 1.7, the chain rule, right? And so this is another, I consider it to be a shortcut, but it's a differentiation technique, right? The objectives here, we like to find the composition of 2 functions. Hey.
Morehouse?
I actually made my own Morehouse ringtone. That was me receiving the email. I'm pretty sure somebody's in the waiting room. I'll get them. I'll check. If you come late and it's before 15-minute mark, just wait until the 15-minute mark and somewhere between 15 to 20 minutes. And I usually do a second wave of attendance. Objectives: find the composition of 2 functions and differentiate using the chain rule. Okay, let's come on. No, why are you doing that? There we go. It's looking good. So we have this definition. It says the composed function. Okay, let me mark this. All right. You're kind of lagging a bit. The composed function f composed g, right? So this symbol, this open circle, a common error is that students think that means multiplication. That's not multiplication. What this means is the second function inside the first function, all right? F composed G, the second function inside the first function, all right? So what we're going to be doing with this composition of functions, we're going to write the first function like normal, but we're going to replace each x with this entire function, okay? So this is the composition of f and g, and it's defined as f composed g is going to be f of g of x, okay? So that should be from college algebra, that should be okay. So for this f and g, find f composed g and g composed f, right? Not too bad. Okay. So let's do f composed g. And usually, like whenever I'm working, when I see the letter G, I think the color green. So if we're going to do F compose G of X, and I'm going to do G in this color green, okay? This means F of, we're going to replace each X there with the green thing, okay? So this means we're going to say F of, and the green thing in this case is 1 plus x squared. Okay. So what this means is that all we're going to do is write f like normal, but replace each x with the green thing. Okay. So then f in this case is now, when I go to do my substitution, first I'm going to replace the x with a blank set of parentheses. So each x is going to be replaced with a blank set of parentheses. And then what color in this case am I going to put in the blank? The green thing. 1 plus x squared. Okay. I wonder if we can just leave it like that. Do we need to expand this out? Let me see how they did their answer. Okay, let's go ahead and expand it. So if we expand this guy, we're going to have a 1 plus x squared. And then now if I FOIL, that's going to be 1 plus 2x squared plus x to the 4. Now I just distribute, right? Like every component in the binomial times each component in the trinomial, right? That's essentially what we're doing. So that's going to give us 1 times 1 is 1 plus 2x, what is that, squared plus x to the 4. Now I'm distributing my x squared, right? Basically, I said 1 times each of these components, terms, and then I'm going to say x squared times each of these terms, okay? So then that's going to be x squared plus 2x to the 4 plus x to the 6. And then if we combine like terms, I guess we can go here. And I'm going to put it in descending power order just for the sake of doing it. X to the 6 plus 3x to the 4 plus 3x squared. And that's it, plus 1. This is what we got when we did F compose G. Okay. 4, 5, 5. Okay. Yeah, they did an update, so everything looks different. It's kind of interesting. Let's copy. Okay, so then when we do G compose F, now we're going to reverse the order. Let me see. I'm just going to give myself some space. Let me copy, paste. All right. So then I can clear this page. All right, so let's do G compose F. What's the time? I'll take attendance as soon as we finish this one. So then G compose. Now, when I think F, I think fuchsia, right? Which is, I think, like this hot pink color. So I'm gonna do that one. So it's fine. That's what I have with everything else. Okay. So what this means, we're gonna say G compose F means G of f of x, the second function inside the first function, right? G of f of x. So all we're gonna do is write G like normal, but replace each x with the fuchsia color. So first, and this is gonna be G of f of x is x cubed. Okay. And again, if anything is not clear, feel free to unmute yourself to get my attention. That's the recommendation. Okay, let's keep going. So then G in this case is 1 plus x. Oh, no, we need to do a blank parentheses. And in the blank parentheses goes the fuchsia thing. So this one seems a lot more simple. Notice we are not getting the same thing. A power to another power, like Bebe's kids, we don't divide, we multiply, right? I know that's an old one. 3, we multiply. So x to the power is 6, yeah? 1 plus x to the power of 6. I guess we could have done this on the previous slide, but that's fine. No, thought I copied it. Let me copy, paste. Okay. And I think I am just going to go ahead and move this. Let me cut. Just move it to the previous slide because we got enough space. Just like that. Okay. And then let me delete this. Nope, not that one. Delete. Okay. All right. Let me wrap this one up. Then I'll check attendance. to the 6, 3x to the 4, 3x squared plus 1. You see it there. It's in a reverse order, but that's fine. That's not a big deal. 1 plus x to the 6, okay? All right, let me check on you guys. Zoom. Okay. I know I let him in. I don't know what's going on with this. Let me get this student. Let's see. Get it.
I switched from my phone to my computer.
I figured as much. Yeah, that's okay. I just as long as you're in there. Okay, that's fine. That's not. I think that was everybody. Just wanted to make sure you was okay, because it kept like I was like, I know I took his attendance. I saw it like a couple of times. I was like, oh, that was going on. Okay, let's see. So we finished that one. Let's go on to the next one. I think we got the latecomers, so I think we're good to go there. With this example, given this f and this g, fine, same thing, right? F compose g and g compose f. Let's knock it out. Okay, so f compose g of x, right? I like to do my g's in green. Again, this means f of g of x. This table is loud. Trying to stop it from shaking so it can stop being so noisy. This means f of, now g of x in this case is x minus 1. Okay. And our f in this case, so square root of x minus 1. Dog decided to go on the prowl. She's like circling me like Jaws. I think she knows some food is afoot. I do have some food on the table. Anywho, I think that's it for that one, right? So let's go with that. Oh no, what did we hit? Let's paste. Nope, undo. Do this. So hopefully you guys are like, you know, enjoying your time at the house. Copy. You know, working hard, but then playing hard. Like try to enjoy yourself. You know, do what you need to do, but then, you know, your college experience is whatever you make it. Okay, G compose F in this case. This means G of, now the inside function in this case is F of X, okay? So this means G of, now F of X in this case is square root of X. Okay, let me move this over. Okay. So our G is X minus 1. So I'm just going to put it, I mean, really we should do a blank parentheses minus 1, and then it should be just square root of X. Okay. And we can actually just lose parentheses. It's not for her bad. Okay. So we're here. Okay, so notice the difference. Let's copy, paste. Cool. All right, so the order is important when we do composition. It's not closed, it's not commutative. This operation is not commutative. The order, in other words, we're saying the order is important, which we do it. It'll affect the outcome, okay? So you see, here's a type version of what we just did. Okay. So the quick checks I usually leave as an exercise for you. And we have this theorem, it says the chain rule. So it says that the derivative of the composition f compose g is given by this guy here, all right? So this is read d by dx, or the derivative with respect to x of this composition of function, right? So d by dx of this guy. So in order to do d by dx, the chain rule, basically it's going to be the derivative of the outside function times the derivative of the inside function. Okay. So when we go to do the derivative of a composition, again, it's going to be the derivative of the outside function times the derivative of the inside function. Okay, let's see if we can see this in action. So for this y and this u, find the derivative of y with respect to u. So just take the derivative like normal, just, you know, do it in terms of u instead of x. Then it asks us to find the derivative of u with respect to x. Okay, so same thing there, just take it like normal. So then if we apply the chain rule, if we did dy by dx, I want to say we can essentially just multiply those results, right? Because that's what the chain rule is: the derivative of the outside function times the derivative of the inside function. Okay, so let's do those parts. I don't think I thought about it like that before, but anyway. So if we're going to find the derivative of y with respect to u, okay, let's see. So I'm just going to kind of write the result, right? So the derivative of a constant, that derivative is going to go to 0. This is u to the 1/2, right? So before we said the derivative of this guy is like the derivative of a power function. So in other words, the 1/2 comes down. We're still going to have u, but then if we subtract 1, that's going to be u to the negative 1/2. Okay. And I'm going to write it as square root of u. Let's clean that up. U, there's a 2 here, and it's all in the denominator, right? Because the negative moves it to the denominator. All right. I'll make sure that you get your back. Get down, please. Thank you. It's so funny when she listens to me. I asked her to get down. She just sat and looked at me. Anywho, okay. So that's the derivative of y with respect to u. Let's go ahead and find the derivative of u with respect to x. So du by dx, right? So yes.
How'd you get the 1/2 times u to the negative half power?
Okay. So last time we said, so we were basically here, right? Taking the derivative here with respect to u. The first thing we do is we take the derivative of this constant, all right? The derivative of a constant we said was 0 last time, all right? So that one's just gone. And then this guy, the derivative of square root of u, what we did is rewrote u as a power function. So square root, let's do this in purple. So the square root of u is the same as u to the power of 1/2. Then I applied the power rule from last time, where the 1/2 comes down and you subtract 1 from the exponent. And that's how I got that result. Yeah, that's how I got that. Hopefully that answered the question. If we're taking the derivative of u with respect to x, okay, same kind of deal, right? So if we focus on this first term, the derivative of x cubed, what happens? So then that's going to be 3x squared. And then we just said that the derivative of a constant is 0. So that term is gone. Okay. So the derivative of u with respect to x is going to be 3x squared. So I think we just said, right? Now, if we want to find the derivative of y with respect to x, dy by dx, the derivative of the outside function is going to be dy by du. So they said the derivative of the outside function times the derivative of the inside function. So that's going to be your du by dx. All right. You can, it's almost, I don't want, let me not do that because I feel like that's going to lead you astray. But I will say, I am tempted to say, essentially, it's like we're canceling these guys out, but you do have to find this guy first and then this guy and multiply your answers, right? So dy by du, let me think about this. We might have to substitute in, right? If we say dy by du, we got 1/2 times the square root of u, right? Times du by dx, we get a 3x squared, but these are, the units are kind of weird, right? We got a u here and an x here, and we want it y with respect to x. So I think what we need to do is plug u in here to get it into the proper form. Okay, so there's one more additional step. U we have at the top is x cubed. So on bottom, we're going to have 2 times the square root of x cubed plus 1. So all I'm doing is replacing u with the original u, right? And on top, if it's just going to be what, the 3x squared. Hopefully that made sense. If it didn't, we can talk about it. Let me do a quick recap. Let's just kind of go over that one more time. Okay. So with this example, right? They gave us y in terms of u. They gave us u in terms of x. Okay. First, they asked us to find dy by du. We got this result. Then they asked us to find du by dx. We got this result. Then in order to find dy by dx, we took the first result times the second result. You see it here. But, we don't usually leave it with like that. So all we did was take the original u and replace it here. That was the only change we made. Okay. Let's let me see. So we got 3x squared over 2 times the square root of x cubed plus 1. And you see it there. Right? And I think they have the exact same steps. You can see they had the u there with this guy, and then they plugged the original in and kind of condensed it. So, okay, that was interesting. I think I saw a presentation like this. Yes, go ahead.
So they just substitute the original u in the function.
Mm-hmm. This guy right here, because the last two parts, this and this, are the exact same. The only difference is they replaced the u with the original u.
Oh, okay.
Mm-hmm. Okay. Okay. Let's see what else we got. So that was example 3. So again, the quick checks I leave as an exercise for you. For this y and this u, find dy by dt. Okay, let's do it. Right? Let's do it the same way we just did the previous. Right? I like how that presentation. So if we want dy by dt, then we need to find the derivative of y with respect to u, and we're going to say times the derivative of u with respect to t. All right, that's the chain rule. So let's start by let's do the exact same steps. Let's first find the derivative of y with respect to u. Okay. So then that's going to be 2u minus 3. All right, from last time. The first term, just the power comes down and you subtract 1. We got this result. The second one, you can still do the same thing. The power will come down. You will get your -3. And then u to the power of 0 is 1. Okay. Again, with that second term, we can do the same thing. That power of 1 comes part is going to be u to the power of 0. Is going to be, we found dy by du. And I don't want you guys to feel weird about stopping me. I know I feel like I talk fast sometimes. So it's okay. Like if you have a question, just ask. We found dy by du. Let's look at du by dt. My personal philosophy is that the only dumb question is the one that asked. Right? We're in this environment because it's a lab. We're here because we're all growing together. If we knew this stuff, we'd be out, sending rockets into other dimensions and things, right? We're here to learn, not because we know already. There's a part of us that knows, but we're trying to bring it into our consciousness. Du by dt, okay? So basically, we just take the derivative with respect to t. I think it's just going to be 5, right? Because the derivative here is 5. The derivative of a constant is 0, so the only thing that persists is 5. So when we want to find dy by dt, that's going to be dy by du times du by dt. Let's see. So that's going to be 2u minus 3 times 5. But then we need to put the original u back in. So that way it's all in terms of t. And if we distribute, we're going to have 10 times, 5t minus 1 minus 15. Let me expand it a little bit more. That's going to be 50t minus 25. Okay. This is what I got. We got 50t minus 25. Okay. I'm loving that the days are getting longer. I need as much sunlight as I can get, like within reason. And you see it at the bottom, 50t minus 25. Okay. So with theorem 10, it says the extended power rule. Suppose that g of x is differentiable function of x, then for any real number k, so the extended power rule, right? So we saw before the power rule where the power would come down and we would subtract one from the power. Well, now you can take the power rule and combine it with the chain rule, right? So if we had some function raised to some power, right? When we go to take the derivative, the k comes down, we subtract one from the power, just like in the power rule. And then just like in the chain rule, we say times the derivative of the inside function. So essentially it's the derivative of the outside function times the derivative of the inside function. Okay. All right, let's keep going. So we're asked to differentiate here. Okay. So then our f prime. So first the 1/2 comes down. This persists. 1/2 minus 1 is a negative 1/2. And then we're going to say times the derivative of the inside function is just going to be what? 3x squared, right? I mean, we can essentially leave it like that, or we could go on bottom, we're going to have square root of 1 plus x cubed. Okay, you got a 2 here, and on top, we have this 3x squared. So either one. Okay. All right. Let me see. 3x squared. Yeah, you see it there. Okay. All right. Ooh, so we got a couple of things going on here. I see extended power rule. I see product rule, chain rule, several things, right? So it looks like the main operation is multiplication. So we're going to focus on the product rule first. The product rule from last time was first times the derivative of the second plus the second times the derivative of the first, right? So we're going to do that first. So then f prime of x, the first, which is this guy, times the derivative of the second, I'm going to abbreviate it as d by dx of this guy. Okay. So that's the first times the derivative of the second plus the second, which is this, times the derivative, so I'm going to say d by dx, the derivative of the first, 3x minus 5, okay, to the 4. Okay, so now we need to go back and find the derivatives of those components. Okay, so then it's 3x minus 5 to the 4 persists. That derivative, if we apply the extended power rule, the 10 comes down. We're going to have this 7 minus x. That's going to become a 9. And then the derivative of the inside function looks like it's -1. So we're going to say times -1. Okay, there's a lot there. Let's say plus this 7 minus x. That's not a minus x. 7 minus, oh, what can I write today? 7 minus x persists. All right, that whole thing persists. Now when we take the next derivative, the 4 comes down. The 3x minus 5 persists. The 4 now becomes 3. And the derivative of the inside function there is 3. Okay. Now let's see. So it's essentially two main terms. We have the left part and the right part, and I think they have things in common. It looks like they both have. Let me see. Now it looks like we can factor out a 3x minus 5. They both have what? At least 3 of them. It looks like they both have 7 minus x. I'm going to say times 7 minus x. They both have what? 9 of them. Okay. Okay. Now from that first one, let me kind of show my augmentations. I factored this out, and that one of those 3 one of those first ones persists. So negative 10, if we distribute a negative 10 into that guy, that's going to be negative 30x plus 50, okay? And then we're going to say plus for the second part. Now let's see. This 3x minus 5, we took all of those guys out. So they've been factored out. And I think we only have one of that 7 minus x left over. So we need to distribute a 12 into there. So 12 times 7 is 70 plus 14 is 84. So that's a positive 84. And then 12 minus 12x. Okay. Oh no, what's going on? Minus 12x. Okay, I think I got everything. So again, organization and being neat and writing big as you can is important because it is easy to lose track of the stuff. If we combine like terms, I'm going to leave this 3x minus 5 to the third. I'm going to leave that as is. I'm going to leave this 7 minus x to the ninth. I'm going to leave that as is. If I combine like terms here, what is that? 13, so 134. And negative, let's do 134 minus 42x. Okay, we must be halfway. Okay, let me stop. Let me see. Let me paste. We are just about done with this section, so we're moving at a decent rhythm or decent pace. Okay, and we got all of this. We got 3x. Yada yada to the third, 7 minus x to the ninth, 134 minus 42. Oh, they factored out a 2. That's fine. If we distribute the 2, yeah, 134. Yeah, it's the same thing. So they just there was a common factor here. They factored out a 2 from both of those terms, right? But that's fine. Either one is acceptable for me. If you get on an exam and you have something like this, and they should give you credit for that. You know, if you get on an exam or an assignment and you can challenge it. We could talk about it together. If you put something like this and they had something like this, I would give you credit for it, right? I would just give you credit for it. So sometimes you can challenge it if you don't necessarily want to go back and redo it. Okay. Let me just do a quick scan, quick check, right? In section summary. So we did finish this one within the half. Okay. Let me go ahead. I'm trying to think how I want to do it. Okay. Yeah, I kind of want to start a new stream for the second half. So I'm going to stop the live stream. We're going to take a quick pause just for me to get set up for the next part. I'll get him in just a moment. Let me go full screen. Close that. Let me. Oh my goodness, his dog is like driving me nuts. She's just like, her pacing is like so distracting. It's like it's totally making me anxious. Stop the live stream. Yeah, let me stop this.